First of all, I'd like to thank the International Ozone Association for inviting me to make this presentation on the use of ozone in the cannabis market. I've been reporting on water usage in the cannabis industry since I first wrote this article in 2017, Why California's Cannabis Industry Will Lead Water Innovation, that I published on LinkedIn and Water Online. So I was delighted when Tony Sacco of Spartan Environmental asked me to co-author an article on ozone and cannabis production for Ozone News, which was recently published. Virtually all states have some form of legal cannabis, such as medical cannabis, or have decriminalized its use. Most people agree that it's only a matter of time before cannabis will be legalized at the federal level. And once that happens, the trajectory of sales for cannabis flower and the oils used in edible products are projected to grow as forecasted here by Grandview Research. And as it pertains to California, cannabis is the top valued crop in California currently. 60 to 70% of the marijuana sold in the United States is from California. It's $11 to $17 billion per year crop, the value of the total cannabis crop. And compared to the next ranked commodity, which is milk and cheese, it dwarfs the 6.7 billion per year of that commodity. One of the major issues is that cannabis is competing with other agricultural products for water resources. How much water are these farmers really using to grow cannabis, both legally and illegally? And this is especially critical during the drought conditions the Western United States is currently facing. Even in Colorado, the return on invested water is much higher for cannabis than a food staple like potatoes. During her recent keynote address at the recent Wine and Weed Symposium, Terry Wheatley, president of Vintage Wine Estates and chairwoman of the board for CannaCraft, projected the following numbers for cannabis. $420 million by the end of 2021, $1 billion by 2025, and $100 billion by 2030. Besides competing for resources like water and land, another issue, which is currently a problem in the wine industry, is the pungent odor, the skunky smell that is often given off by cannabis that neighboring properties find objectionable and will have to address. With all these factors, that'll lead to the trend that the cultivation of cannabis will head indoors to greenhouses and indoor farms. And like all consumables, cannabis will eventually be required to meet good manufacturing practices. But there has been limited research because since cannabis is a federally regulated substance, universities have avoided research and regulatory framework from federal agencies like the FDA and EPA that are non-existent. So it is up to industry to develop standards and improve operations. So this bodes well for the use of ozone in a number of applications, and ozone is beginning to play a larger role in cannabis production as the market grows. There are a number of areas where ozone can be used, and I'll go through each one of these in turn. First, there's fertigation and irrigation. There's wastewater treatment. There's sanitation. There's air emissions, mostly in the gas phase. And there's disinfection of finished products, also in the gas phase. So as far as water for irrigation and fertigation, water is a vital crop for crop growth, especially in indoor systems. Water delivers the nutrients and other inputs. It's a major cost, and managing every drop is critical. Ultimately, it's about improving yield in terms of both quality and quantity. Cannabis can grow with or without soil, and hydroponic systems. Nutrient-rich fertigation water is a breeding ground for plant pathogens and biofilm formation. And biofilm is a big problem. It can harbor pathogens and plug filters and emitters, especially for water that's being recycled. And then greenhouse and nursery operations are particularly susceptible to these biofilm problems. Ozone can be added to the water to prevent biofilm formation, remove plant pathogens, and add dissolved oxygen to water as it breaks down into O2. Ozone for wastewater treatment, the standards have not yet been defined, but for growers, water that is not recycled will have to be discharged. Ozone can treat this effluent. And for processes, the oils and solvents in wastewater, ozone-based AOP can help, especially as it helps to break down the organics. At the end of one crop cycle and before the beginning of the next one, the entire growth facility must be sanitized. Here's a photo of a mobile cart manufactured by our friends at Clearwater Tech that produces ozonated water to control pathogens, contaminants, and odor. It eliminates the need for steaming hot water, and it's simple and flexible for operations of nearly any size. You can have one of these mobile carts, or you can actually use a standalone system, wall-mounted system that can work well for the application. As I mentioned before, there's a big issue with odor coming from cannabis grow houses and processing facilities. So ozone systems are being installed at the outlet of HVAC systems to mitigate this problem. As the terpenes are released, creating odors, ozone may help in mitigating these odors that are objectionable to neighboring properties. And there are any number of contaminants that can affect quality: mold, mildew, bacteria, yeasts. So ozone in the gaseous phase can disinfect the finished products, but care must be taken to control the dose so as not to compromise the quality, flavor, or effect of the actual product. And here's a schematic from our friends at Oxidation Technologies showing all the ways ozone can be applied in a cannabis operation. Now, not all facilities will use every system shown, but this is a good depiction of the way ozone can be used, the different applications for fertigation and irrigation water, for sanitation, for wastewater treatment, for odor control, and for finished product disinfection. As a quick postscript, upon receiving my chemical engineering degree, I started my career in another agricultural market as a process engineer, production manager, and an environmental manager in the sugar industry. And this is where I developed my early knowledge of water treatment processes: filtration, clarification, activated carbon adsorption, ion exchange, of course, ozone, UV. I did some early work on reverse osmosis membranes. I was responsible for boiler water treatment and also the cooling tower water treatment. And then in the 1980s, I became an environmental manager of one of the world's largest sugar mills, which was located in the Florida Everglades. And besides overseeing the water treatment processes, I was also responsible for all the stack emissions. And since we had the largest furnace in the area, sometimes the county officials would call me and ask if they could burn their outdated documents in our furnace. So imagine my surprise when one day the county sheriffs arrived with a 6-ton dump truck full of all the marijuana they had confiscated, and they wanted to burn it in our furnace. Imagine their surprise when I told the Southern deputies in my New York accent, I was the one responsible for disposing of, quote, their documents. Or as my girlfriend at the time said, the cops show up to burn their stash of ganja, and who was in charge of the operation? But Cheech and Chong's cute younger brother. Up in Smoke, Part 2. Now, I'm not sure what the Guinness Book of Records is for the world's largest bong, but I think I might hold it. And unless Willie Nelson or Snoop Dogg are in attendance, I'll bet I've, quote, smoked more cannabis than anyone in the audience. Any questions?